Hello everyone. Today we're looking at Boolean Logic. This is by IT's Clear. So if you look at Boolean values, you've already probably covered these in Java if you're doing the Java course. A Boolean value can only be a 1 or a 0. Sometimes we refer to it as a true or false. Same thing. True is 1, false is 0. We can also talk about being a Boolean value being on or off. Same thing. On is true or 1, off is false or 0. So we've got logical operators that we can work with using the Boolean values. Like in arithmetic, we have greater than, less than, etc. So to process Boolean values, we are going to use 3 operators: and, or, and not. So let's look at these. So let's look at and in more detail. I know you all love peanut butter and jam sandwiches. So some people only like peanut butter and jam if it's mixed together. This is the and function. They don't want a peanut butter only sandwich or a jam only sandwich. It's got to be the two mixed together. The or function is if you like peanut butter on a sandwich by itself or jam on its own, or both mixed together. That's the or function. And then the not function is you don't like jam. You only like peanut butter on its own. That's not jam. So just a little illustration. Let's look at them in more detail. The not, if we have not of a true function or true value, we actually get a false. Not of a false gives us a true. So not just means the opposite. If the light bulb is not on, then it's off. So the important thing we're trying to get at here is to draw truth tables. So the not of a 1 is a 0, the not of a 0 is a 1. When we have a truth table, we're going to make columns. So here, when we have not A, we only have one input, that is A, and our output is not A. So A can only take on the value 0 or 1, and therefore not A will only also have two values, 1 or 0. And it needs two inputs. So for example, we can say A and B and get an output. So and is only true when both inputs are true. You could look at this little circuit here that I've got on the right. We've got two switches in the one circuit. We've got a battery, two switches, and then a little light bulb. So you can see that to switch the light bulb on, we are going to have A switched on and B switched on. So that's like when A is true and B is true, then yes, Q, the light bulb, is on, which is true. So if we draw the truth table, we have two inputs now, A and B. So we've got to consider all the possibilities for A being 0 or 1 and B being 0 or 1. So to do that, we do a column for A and a column for B. We start with 0, 0, then 0, 1, then 1, 0, and 1, 1. You can see we've thought of all the possible combinations of zeros and ones for A and B. And then we go and fill in what A and B must be. So if A is 0 and B is 0, A and B will be 0. Just think of the light switches being on or off. If A is switched off and B is switched on, the light bulb will still be off, so we get a 0. Third row, if A is switched on but B is switched off, the light bulb's still off, so A and B is 0. And only if A is 1 and B is 1, so both light switches are on, then we get a 1 on the output. The OR operator also needs two inputs. For example, we're going to say A or B gives us an output. The OR is true when either input is true. So if you look at my little picture of the circuit, you can see that if I either switch A or switch B or both on, then the light bulb's going to switch on. So that gives you a good way to remember the OR. The two switches are in parallel. So the OR truth table, we've got the column for A, column for B, and the last column for A or B. If we've got 0 or 0, so both light switches off, A or B is 0. A is 0, B is 1, only light switch B is switched on, A or B is 1. A is 1, B is 0, we get A or B equal to 1, and if both switches are on, A is 1, B is 1, we get A or B equal to 1. So let's practice a little bit. I want you to write down your answers. I'm going to go through them now if you want to pause the video. So not of 2 greater than 1. We've got to think about this. 2 greater than 1. 2 greater than 1 is going to be true. So you could put a little true here. And the not of true is going to give us a false. Then 6 greater than 9 is false. So the not of a false gives us a true. And 5 equal to 4 is false. So the not of a false is true. Okay, and let's look at the results. We've got false, true, and true. So we got those all right. Let's practice AND. So as you can see, I've got 2 conditions on either side of the AND. 5 equal to 2 and 3 equal to 4. Those are questions. Is 5 equal to 2? Is 3 equal to 4? The answer is going to be a true or a false, a 1 or a 0. So is 5 equal to 2? Just switch my pen on. No, that is false. Is 3 equal to 4? No, that is false. So is a false and a false will give us a false. Right? Is 4 greater than 3? Yes, that is true. Is 5 greater than 2? Yes, that is true. A true and a true is going to give me a true. Is 3 equal to 3? Yes, that is true. Is 10 greater than 9? Yes, that is true. A true and a true is going to give me, again, a true. This one's got little questions which I want you to answer. I hope you will all answer yes or true to these. I am clever, true. I am hardworking, true. A true and a true is going to give me a true. So let's look at the answers here. So we've got a false at the top, a true, and a true. So I hope you got those all right. Last of all, let's practice our ORs. So let's think about it. Is 5 equal to 2? No, that is false. Is 3 equal to 4? That is false. A false or a false is going to give me a false. Is 4 greater than 3? Sorry, that is true. Or is 2 greater than 5? No, that is false. But we know that with an OR, either input can be true and the output is true. So a true or a false is going to give me a true. Then is 3 equal to 3? That is true. Is 8 greater than 9? That is false. But a true or a false is a true. So we've got a true on the output. I am sporty. Well, I'm not really sporty. You can answer this as you see fit. No, I'm going to put false. Am I friendly? I am friendly. And that is true, yes. So my overall output is true. A false or a true is a true. Then we've got a slightly more tricky one. Here we've got not 5 greater than 6 or 8 greater than 9. So 5 greater than 6 is false. But when I say not of this false, I get a true. So I'm going to put my true there. Is 8 greater than 9? No, that is false. but I've got a true or false. So that is going to give me a true. So those are all my answers for the ORs. Let's look at the answers. We've got a false, true, 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 and true. So we got them all right. And let's carry on. Here is the order in which operators work. You know that in arithmetic you just got your BODMAS. That's how you remember the order of operations. Here you've just got to remember it goes to brackets. Brackets always get done first. Then if you've got a not anywhere, that gets done. Then the and then the or. And also there is a different notation which we use for not and an or, which you must please remember. For the not, we use a little dash like that. So a dash means not a. For the and, we use a dot. So if we say a dot b, that means a and b. Sometimes you might even find there's no dot. They just put AB. It's like in maths. If you put AB, you know it's A times B. But in logic, Boolean functions, it's A and B. Okay? And then the or is a plus. So A plus B is not A plus B. It's not addition. It's A or B. Okay? So please remember those. Let's do a slightly more tricky logic sum. We've got 6 greater than 4 or 3 less than 2 and cats are cool. So here the best is to just work out every little condition separately and then to do the logic part of the sum. So is 6 greater than 4? That is true. Is 3 less than 2? That is false. Are cats cool? Yes, they are. That is true. So remember that we always must do the and part first. It comes before or. So we've got false and true, which we know is false. And then here we've got the true, which you can bring down, or false. And we know that a true or a false gives us a true. So our final answer here is true. Another one. Sometimes you don't have A, B, and C's, or you've got to think logically about things. So we've got cats hate people and cats are clean or cats are clever. Cats hate people. Now that's a myth that they do hate people. So it's actually true. I mean, it's actually false. They do not hate people. And cats are clean. Yes, cats are clean. That is true. They're always licking themselves and they're very clean. And cats are clever. That is also true. So we've got a false and a true. Remember, with this time we can do the and first. It's on the left as well, so it makes but remember that ands always come first before ors. So unless the or is in brackets. So here we've got a false and a true, and that we know gives us a false. And then we've got false or true here, and that is going to give me a true. So my overall answer is true. Right. So often you'll be given a whole little Boolean sum and you'll be asked to draw a truth table. So the way you go about it, create a column for each input, then create a column for each condition. Like, I mean, is A greater than B, or is 5 greater than 4, whatever it is. Then once you've got a column for each little condition in the whole sum, you've worked out your final answer. And remember the order: brackets, not, and, or. So let's do this, an example for you. If we've got A or not B. Now over here at the top I've put the sum completely written out for you, but in the table I've used the notation so you can get used to it. So remember that if we've got 2 inputs, we've got 4 possible combinations. So we've got 0, A is 0, B is 0, or we can have A is 0, B is 1, or we could have A is 1, B is 0, or we could have A is 1, B is 1. Now we've got to work out not B. So I've put B dash here using the shorthand notation. So not 0 is 1, not 1 is 0, not 0 is 1, and not 1 is 0. Then over here at the end, we've got to work out A or not B. And now I've got to be very careful. I'm going to have to focus on this column where my A is, and this column where my B dash is. I mustn't look at the middle column where the B's are, or I'll get confused. Okay, so I want A or not B. So I'm going to use those two columns highlighted in red. So 0 or 1 is 1. 0 or 0 is 0. 1 or 1 is 1. And 1 or 0 is 1. And that's my truth table all drawn up. Then another example. We're going to do not A and B. Again, we've got two inputs, A and B. So we need to put all possible combinations, 0, 0, 0, 1, 1, 0, and 1, 1. Then I've got to work out not A. So I'm going to have 1, not 0 is 1, not 1 is 0, and not 1 is 0. Then I'm going to have to do not A and B. Again, maybe I can highlight. If you want to work in colors, you're most welcome. There's my not A, and there's my B column. Okay, it's still simple at this stage, but it can get quite tricky. You can have like 5 columns going across your truth table, and at that stage you might like to color coordinate things. Right, so you've got not A and B, and we're going to have 0 and 1 and 0, 0 and 0 is 0, and 1 and 0 is 0. Oops, my first 0 disappeared. That is 0. And there's my answer. Right. So here's our next example. We want to work out A and B or C. And you can see now we've got 3 inputs. So we're going to have to type in 8 different possibilities. If we've got 3 inputs and each of the inputs can be 0 or 1, there are 2 to the 3, which is 8 different possible combinations of 0s and 1s in A, B, and C. We're going to start with 0, 0, 0, then 0, 0, 1. Basically, I'm just counting in binary. 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Sorry, my columns are a little bit messy, but you get the idea. Okay, next we're going to work out A and B. There it is, A and B. Here I've got it in a different notation, A dot B, which means A and B. So we're just going to be looking at the first 2 columns. 0 and 0 is 0. 0 and 0 is 0. 0 and 1 is 0. 0. 1 and 0 is 0. Same thing. Then 1 and 1 is 1, and 1 and 1 is 1. Next, I'm going to go and look at this result, A and B, or C. So I need to be working in those 2 columns, and I'm going to do that. So I've got A and B or C. So there's my 0 and another 0, and I need to OR them. So 0 or 0 is 0. 1 or 0 is 1. Remember, I'm only looking at the 2 columns that I've highlighted in red. Maybe we should circle them again. This column, which is C, and this column. Okay, the C comes second in our little sum here. But remember, it does the order of operations, whether we swap A and B or C or put it C or A and B, it doesn't matter. Okay, so let's carry on. So we've got 0, 0, 0, 1 or 0 is 1, 0, 0, 0, 1 or 0 is 1, 0, 1 is 1, 1 or 1 is 1. And that's our final answer. This is example 4. Let's read the problem. The sum, it's brackets A or B, close brackets, and brackets B or not C, close brackets. So we've got 3 inputs, A, B, or C, A, B, and C. And we're going to put in the columns, we're going to work out bit by bit the different parts of this sum. So in the first part, we'll do A or B, and I'm using the shorthand notation. In the second part, in the second bracket, which is we've got to work out next, we've first got to work out the not C on its own. So I'm going to put C dash there, and then we'll be able to work out the whole of the second bracket, which is B or not C. And then right at the end, we'll work out A or B, which we'll have in that fourth column, and B or not C, like that. Okay, so first of all, we've got to fill in all our possible inputs. We've got 3 inputs, so 8 different combinations. Remember, for this part, you just count in binary. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now we'll be able to work out A or B looking at the first 2 columns. So we've got 0, 0, 0, 0, 0, 0, 0 or 1 is 1, and the same. 1 or 0 is 1, and the same. And 1 or 1 is 1, and that's the same. Then we want to have C, not C. So I'm just going to look at column C and do the opposite. So it goes 1, 0, 1, 0, 1, 0, 1, 0. Next, I'm going to do B or not C. So for this, I'm going to start highlighting the columns because this is easy to get confused at this point. I want this column, column B, and I want column not C. Those are the 2 columns I'm going to be working with. You can put your fingers on those 2 columns as you work down the column. I find that helps me. So B or not C. 0 or 1 is 1. 0, 0 is 0. 1 or 1 is 1. 1 or 0 is 1. 0 or 1 is 1. 0 or 0 is 0. 1 or 1 is 1. And 1 or 0 is 1. And then we want the last column. We're ready to do the whole calculation. So we've got A or B and B or not C. And we're going to focus, I'm going to highlight the 2 columns in blue this time. I'm going to focus on the A or B column and the B or not C column. So those 2 columns. And let me change my pen to black. Okay, and let's go. So this is an AND. Remember, it's an AND between the 2. So 0 and 1 is 0. 0 and 0 is 0. 1 and 1 is 1. 1 and 1 is 1. 1 and 1 is 1. 1 and 0 is 0. 1 and 1 is 1. 1 and 1 is 1. And that's our final answer. And our truth table is completely filled in. So bye, and thanks for learning today. Please like this video and subscribe. Thank you very much for watching. Bye.